Two-dimensional shapes, right? Two-dimensional shapes are shapes that you can draw on a piece of paper, right? They are the shapes you learned in kindergarten, okay? Like a square and a triangle and a circle. And then probably second grade, you learned other shapes, hexagon, octagon, okay? These are all polygons, right? A polygon, poly means many. A polygon is a shape that has multiple sides, and all the sides are straight lines. All the sides are straight lines. So these are all polygons. Now, a regular is an important word to know. A regular polygon means all of the sides are the same length and all of the angles are equal. All of these pictures here are regular polygons. Okay. This one, a regular triangle. We call this a what kind of triangle?
Triangle.
Equilateral, right? All the sides are the same length. A quadrilateral, a regular quadrilateral that has all sides the same length and all angles the same is called a square. This is a regular pentagon. Okay, all the sides and angles are the same. This is also a pentagon. Right? It's a 5 straight sides closed figure. So this is also a pentagon. It's not regular because the angles are all different. Right? You're used to seeing them all have the same length sides and all the angles being the same. But a pentagon just has 5 straight sides that are closed like this. James. No, a regular pentagon has all obtuse angles, right? Everything past the square, all the angles are obtuse, right? They actually, the angles all, yeah, there's a way to calculate what the angles are, which you'll do in geometry in high school, okay? Quadrilaterals are 4-sided, right? That includes trapezoids, parallelograms, rhombus, a regular quadrilateral that has all different sides, or a square. Circles are also 2-dimensional figures. They don't have straight sides, though, so a circle is not a polygon, but it is a 2-dimensional shape. Yes, Roman?
Circles actually have infinite amounts of sides.
That is true. That's how you can actually do an approximation of pi. You can actually do this thing where you just keep making the sides shorter and shorter and shorter and shorter, and you kind of show what happens. One of the proofs of where pi comes from. Okay, so you've worked polygons already for several years of school, right? 3-dimensional shapes, there are several types of them. The ones we concentrate on in 7th grade are in 2 categories. Okay, 2 categories. Sorry about that, Shiloh and Nachalise and everyone watching this video. That was Grayson flipping the camera. In a fit of rage, Grayson flipped the camera. All right, so there are 2 types. The first type is a prism. Okay, a prism has 2 polygon bases. Okay, they can be any shape, any polygon. This is a rectangular prism. This is a hexagonal prism because the bases are hexagons. This one is a triangular prism. The sides of prisms are all rectangles that join the 2 bases together. Okay, these are prisms. Hexagonal prism, rectangular prism, or square prism if the base is a square, triangular prism. Okay. The other shape is a pyramid. Now, most people, when you think of a pyramid, think of this shape, the Egyptian pyramid, which has a square base, okay, and then has 4 triangle sides that all come to a point. This is also a pyramid. It has a triangle base and triangle sides that come to a point. This is also a pyramid. It has a hexagon base and 6 triangles that come to a point. It's a hexagonal pyramid, right? So the base tells you what type of prism or pyramid it is, the shape of the base. Pyramids have 1 base. prisms have two, one on each side. And then if it comes to a triangle, it's a pyramid, triangular pyramid, hexagonal pyramid. And if it's two bases with rectangles in between, it is a prism, okay? So you need to be able to name these shapes. Is it a pyramid or a prism? This first one is a prism because it has all rectangle sides. This is a pyramid, right? So we shouldn't have too much trouble with that. This one, also a pyramid. And this one is the trickiest one. Oh. So let me point out two things here. Yes, James. Okay, how do you know this is a prism? It has three rectangle sides. What is the shape of excuse me. What is the shape of the base of this prism? Who said rectangle? Yeah, so Alicia says the base of this is a rectangle because the bottom is a rectangle, okay? But that's not what the base of a prism is. The base of a prism isn't the side that's on the bottom, okay? It's the two shapes that are congruent, the two shapes on the ends that are not rectangles. Now, the confusing one, of course, is if it's a rectangular prism, then you could call any of them the base because everything's a rectangle in a rectangular prism. But for every other prism, the base is the shape that's not a rectangle. This is a triangular prism, right? That's what this thing is. This is a triangular prism. This one is a right triangular prism as opposed to an equilateral triangular prism. So you got to be careful on this one. The Rock and Roll Hall of Fame looks like this. It is a pyramid, right? I think it's a rectangular pyramid. I don't think the base is a triangle. Okay. Yes, Roman.
When looking at the equilateral triangle, I actually had a thought. Is it possible to have an equilateral triangle where all sides are 90 degrees?
No, you can't make a triangle with more than one 90-degree angle, right? Because then it would be like a square that doesn't close, right? As soon as you try to close it like this, the angles go acute, right? Okay. Three-dimensional figures have some vocabulary, again, things we need to talk about. So a plane is a straight, like, piece of paper, a flat surface. Okay, this, in real life, there's no such thing as a plane because everything has width, right? But if this didn't have any width at all, right, it would be a plane. So planes, P-L-A-N-E, planes can be parallel, right? So they never intersect. Like these two planes are parallel, right? So the points never intersect. Or they can intersect at a line, right? Where these two planes come together is a line like this one, okay? If there's three planes intersecting like this, the only point that's on all three of these planes, the yellow, the green, and the blue, is this point A in the middle. So the three planes intersect at a point, okay? If they don't intersect at all, they're called parallel planes. Points that are on the same plane are called coplanar. Okay, points or lines that are on the same plane are coplanar. Like these two lines, LM and MN are coplanar. LM and RS are not coplanar. They're not on the same plane. Okay? All right, so three-dimensional figures have three characteristics associated with them that we need to understand. Faces, edges, and vertices. Vertices is the plural of vertex. Okay, one vertex, multiple vertices. Okay, so the faces of a three-dimensional figure are the flat surfaces, the planes that make up the figure. Okay, so in this cube here, like this front here would be a face. Okay, the sides of the shape. Okay, then you have edges. Edges are the lines where two planes come together, where two planes intersect. Like that line there is an edge. Okay, so is this one. So is this one. Those are edges. Then the shape has vertices. A vertex is where three or more edges intersect. It's the corners of the shape. This point, this point, this point, this point. Those are all vertices. The plural of vertex. The plural of vertex is vertices. Okay? Diagonals are points in the shape that go from one vertex to another through the middle, but we don't really care about this so much. Okay? So a polyhedron, which is what pyramids and prisms are, they are polyhedra, are shapes where all of the sides are polygons, right? Prisms have two bases that can be any polygon and a bunch of rectangles. Pyramids have one base that can be any polygon and a bunch of triangles, right? All the sides of polyhedron are polygons. There are special polyhedra that have all congruent faces. All the faces are the exact same shape, like this, where all of the faces are squares that are the same size. This is called a cube. A cube is a rectangular prism, but all the sides are squares. All the faces are squares. This shape, close to, it's a triangular prism, but if all these triangles were exactly the same, equilateral triangles, all four of them, this would be called, it has another name, called a tetrahedron. Tetra means four. Okay, so a tetrahedron is a four equilateral triangles that make a three-dimensional shape. Okay, you can also have a dodecahedron. That's 12 pentagons, 12 regular pentagons that go together. There's an icosahedron. There's other three-dimensional shapes. You don't have to know any of them. Okay. All right. What you do need to know is how many edges, how many faces, how many vertices a shape has. And one other thing that's a relationship of the lines of the edges of a shape. Okay. So the edges of a shape can have three different relationships. If the two lines are coplanar, right, they're on the same plane and they never intersect, like this line and this line, those are parallel lines, which you know that word from before, right? These two lines never intersect and they are coplanar. Okay, they never intersect. In this diagram, there are lots of lines that intersect, like these two edges intersect, and they intersect at a right angle. They are perpendicular, okay, but they're also intersecting. So parallel lines, coplanar, never intersect. Intersecting lines, they intersect at one point, and if they intersect at a 90-degree angle, they're called perpendicular lines, okay? And the last one, which is a new word for you this year, are two lines that are not coplanar, but they never intersect, like this line and this line, okay? These two lines never intersect, but they are not parallel. The word for two lines that are not coplanar and never intersect is skew. They are called skew lines. Two lines in three-dimensional space that never intersect and are not coplanar. Parallel lines never intersect, but they're like train tracks. Skew lines never intersect, but they're not in the same plane. Okay? So you need to be able to identify the relationships of lines, edges in a three-dimensional figure. So let's take a look at some in this picture. What is the relationship between line GH and CD? GH and CD, that's these two red ones, which I randomly chose the same ones. How do you describe GH and CD? They are what kind of lines? GH and CD. Parallel is correct. Who said that? Alicia? Parallel lines. Okay. GH and DH. GH and DH. That's this one. Oops. This one and this one and this one. GH and DH. What is the relationship of those two lines? They are, Holly? They're intersecting, and they also, because this is a cube and intersect at a right angle, they are also perpendicular, okay? I really should have used intersecting here instead of perpendicular, but I'll just write it in. Intersecting. Right? They cross at a point. They connect at this point right here. All right, last one here, GH, and AD. This one. GH and AD. What is the relationship of those two lines? GH and AD. They are what kind of lines? Roman. They are non-coplanar and they never intersect, and we call that skew. Skew lines. SKEW. Skew lines never intersect and they are not coplanar. Okay? Good. We'll skip the last two. All right. There are also three-dimensional shapes that are not polyhedra. They're not made up of polygons. They're circular. A cylinder is like a prism, but the bases are circles. So the sides aren't rectangles. It's just like one big side. A cone is like a pyramid, but its base is a circle instead of a polygon. It doesn't have triangle sides. It has like this one wrapping side. A sphere, that's just like a circle, a ball, and a hemisphere, right? So these are other three-dimensional shapes. Next year, your work in three-dimensional shapes is all circle, cylinders, cones, and spheres. Easy. Semisphere? I don't know. Good question. Semicircle, right? You don't call it a hemicircle, but it's a hemisphere. I don't know why they could be. I don't know. All right. What you need to be able to do from this lesson today is identify the shape. What is it called? And how many what the base shape is, which you kind of need that in order to name it. How many faces, edges, and how many faces, edges, and vertices it has, okay? And you might need to identify the relationships between some of the edges. Are they parallel? Are they skew? All right. The book has you labeling all of the faces, all of the edges, like by using the letters to label the shapes. If you put the letters of all the vertices in a row, that's how you would label like triangle RQS, right? Or the two letters that define a line, like line edge RS, edge ST, edge UT. I'm not worried about that part. All you're going to need to do is count them, okay? So this figure in the examples here, this one is a pentagonal pyramid. Why is it pentagonal or pentagonal, some people would say? Because the base is a pentagon. And it's triangles that come to a point. So it's a pentagonal pyramid. Pentagonal pyramid. Now this says name the bases, faces, edges, the faces, edges, and vertices. I'm just going to ask you how many there are. How many faces does this shape have? How many faces? Alicia? How many faces does this pentagonal pyramid have? Alicia? 6 is the correct answer. it has the base, the pentagon base, and then 5 triangles, right? Each side of the base has a triangle coming off of it. So that's 6 faces. How many, that's these guys. Okay, those are faces. All right, how many edges does this figure have? How many edges? Amanda? 10 edges. 10 edges. Okay, the edges are the 5 at the bottom, and then there's 5 going up from those 5 things at the bottom. So there's 10 edges. And finally, how many vertices does this shape have? How many vertices? How many corners? Nate? 6. 1, 2, 3, 4, 5, 6 vertices. The corners. Okay, that's what the vertices are. Then it asks you to identify skew lines in this picture. So skew, what line would be skew with ST? RV is not skew with ST because they're in the same plane. Those 2 lines eventually would intersect way out here somewhere because they're coplanar. Okay, what's skew with ST? There are 3 choices. QV. QV is skew with ST, right? In the back, right? So that's like my pentagonal pyramid, right? So this line here is ST and QV is back here. Those 2 lines would never intersect and they're not coplanar. Okay, good. This figure is a rectangular prism. In a rectangular prism, you could name any of this rectangles the base because everything's a rectangle in a rectangular prism. It has 6 faces. 6 faces, 6 rectangles. It has 12 edges, right? 4 on the bottom, 4 on the 4 on each side, and then connecting 4 more. That's 12. And it has 8 vertices, 8 corners, right? All right. So in this got it on page 595, go ahead and identify what the shape is. What is its base? What is the shape of the base? You don't have to label the bases, the faces, edges, and vertices. Just answer how many there are. And then identify a pair of skew lines. Got it. Letter A on page 595. What's this thing called? A triangle? This is a triangle. This is a pyramid, and the base is a triangle, so it is a triangular pyramid. A triangular pyramid. Okay? And the triangular pyramid, because all the sides are triangle, well, never mind. What is the shape of the base of this figure? Alicia? It's a triangle. It's triangle JML. Okay, but really we just needed to say it was a triangle. All right, how many faces? How many faces, Grayson?
4.
4 faces. 4 faces. That's these 4 triangles. This one, this one, this one, this one, right? All the polygons, all the triangles. That's terrible. Okay, how many edges does this shape have? How many edges, Kenny?
4.
4. Oh, people are arguing with you. 1, 2, 3, 4, 5, 6. 6 edges. How many vertices, Evie? How many vertices does this shape have? 4. 1, 2, 3, 4. Identify a pair of skew lines on this picture. Evie.
JL and KM.
JL and KM. That's exactly the example I would use, and there it is. JL and KM are skew. JL in the front here and KM going like this. They'll never intersect and they are not coplanar. Perfect. Okay. This one is not in your book. Okay. You can draw it in there in the green space if you like. Okay. The way to draw these three-dimensional figures, some people like, so you start, you can draw two triangles like this, and then just connect the points. And there you have it. What is this called? It's a prism. And the shape of the base tells you what kind of prism. Is the base of this a rectangle? The base of this prism a rectangle? Yeah, this is the tricky one, right? The base is not the one that's on the bottom. The base are the two sides that are separated by all the rectangles, okay? So in anything other than a rectangular prism, because a rectangular prism, any of the sides could be the base, because they're all rectangles. And in any other type of prism, the shapes that are not rectangles, that's the base. So what kind of prism is this, Matthew? A triangular prism. Triangular prism. How many edges does it have, Kylie? How many edges? 9 edges. 9 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. How many faces does it have? Alicia? 5. The 2 triangle bases and the 3 rectangles. 5 edges. 5 faces, I'm sorry. 5 faces. Okay. How many vertices does it have? Emma? 6. That's the corners. 1, 2, 3, 4, 5, 6. Okay. And lastly, what is a line that is skew with AB? Riley, what is a line that is skew with AB? Here's AB. This front bottom one. What is a line that is skew with AB? There are 3 choices. EC. Yep, EC is one. That's good right here. Right, so that's this line and this line. They would never intersect. Roman? FE across the top also skew with AB. And the last one, Evie? DE. Okay, so all of those are lines that never intersect and are not coplanar. Okay? Excellent. Day 2, which would be the next day. So we are done. It's about right because classes tomorrow are only 40 minutes and that's the end of the lesson. So tomorrow, like I said, the white people will have homework. Blue people do not have homework because you're going to be able to finish all of it in the rest of the class today. Now, if you have not finished the quiz, now is the time. Okay? It is unlocked, and so you can open the quiz from yesterday and work on it. I have not posted these 2 problems yet, these 2 assignments. I'm going to do that in the next minute. All right? The rest of you have those 2 assignments to work on. You can go to the IXLs. You can see it's RF6 and ZHF, so you can just pick those up. Identifying the shape, and how many faces, edges, and vertices. That's the kind of questions that we're working on, okay? I'm gonna freeze my screen. Phew. I'm gonna stop recording, stop sharing, stop recording.